Alright, for today's lesson, it's lesson number 91. We are going to be graphing reciprocal trig functions. So remember we talked about sine, cosine, and tangent already, and when we were finding those values for just regular triangles, we talked about how there are three other functions that are the reciprocals of those. So cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Okay, so those are all related that way. We're going to start by filling in the rest of our unit circle table. Then we'll graph the functions on Desmos and sketch the graphs of these in our notes. So we're going to be graphing the three reciprocal functions. So first let's look at the unit circle table. Okay, so here are the values that we have on our table on the back of your unit circle. Okay, you should already have sine, cosine, and tangent filled out. So we're going to be filling in the rest of the chart. You should be filling in cotangent, secant, and cosecant. And again, you can look at the pattern between these. Cotangent is related to tangent. Okay, so these values are the reciprocal of the ones next to it. And then cosine is related to secant. These are all just the reciprocal of these numbers. And same for sine and cosecant. Okay, these are the reciprocal values. Alright, so if you don't have this completed in your table, take some time to pause and do that now. Okay, so then we looked at Desmos to compare the original functions that we're used to with their reciprocal function. So this is cosine and secant. I can change on the graph my step for the x-axis. I probably want to change that to pi over 2. And then my step for the y-axis, I'm going to change that to 1, just so I see all those values. Okay. And I'll zoom in to kind of get a better idea of what these graphs look like from 0 to 2 pi, right? That would be one cycle, or the period for cosine. So I'm looking between those values. I notice that they have some in common, right? These points here they have in common, and then they kind of go in opposite directions. Okay, also right here when cosine is equal to 0, think that right there we would have 1 over 0 for secant, because secant is the reciprocal. So if cosine is equal to 0 at these 2 points, that means that for secant we would be taking 1 over 0, which is undefined. So really we have asymptotes there. Okay, if we look at these lines, we see that the graph of secant gets close, but it never touches them. So if you want to go ahead and go on Desmos at home, if you're following along, you can type in these equations and see this picture on your computer as well. Okay, so again, these green lines here would be asymptotes for secant. Okay, the graph gets close to it but doesn't touch it because it's undefined there. Okay, that's where cosine is 0. So when I take the reciprocal, secant is undefined. So we're going to go ahead and sketch this in our notes now. Okay. Okay, so for graphing it by hand, we would start with the cosine function so that we get an idea of where secant kind of belongs. So I plot these points for cosine, right? Remember, it kind of looks like a V from 0 to 2 pi, but really it has a curve to it, so it kind of looks like this. Now to graph secant, I'm going to start by making the asymptotes wherever cosine is 0. So these will be my asymptotes here. And then I remember they have the point, they have these points in common, right? Wherever it was 1 or negative 1. And the reason for that is just because the reciprocal of 1 is still 1, right? 1 divided by 1 is still 1. If I have, if I'm looking down here, I have negative 1, 1 over negative 1 is still negative 1. So the reciprocal is equal to the original value at those points. Okay, and then for my graph, it goes from that point and it gets close to the asymptote but doesn't cross it. So the first part looks like this, then it looks like this down below pi. And in the last section, it's going to go up close to the asymptote but again not crossing it. Okay, so if I wanted to just look at secant, it would be the parts in red. Okay, so if I ignore the purple, like this would be my actual secant graph. Okay, but I have cosine there just to help guide me with where to draw the asymptotes and where to have these kind of major points. Okay. Now we're going to move on to sine and cosecant. So we'll start on Desmos and then draw it by hand. Okay, so here on Desmos I've changed my functions, right? For the purple function now I have sine. For the one in red right here I have cosecant now, which is the reciprocal of sine. Okay, and I also changed the values for these lines down here. I noticed that this is where the asymptotes are for sine, or for cosecant, since sine is 0 at these points. Okay, so at pi and 2 pi and so on, right? At 0 and then 3 pi, any multiple of pi has sine equal to 0. So those would be asymptotes for my cosecant graph. Okay, and then just like how cosine is related to secant, I have wherever sine is 1, the reciprocal is also 1, and wherever it's -1, the reciprocal is also -1. Okay, and then in between each section, it's going to go kind of the opposite direction of the way that the sine curve is going. So this part, the first piece between 0 and pi, it's opening up, and it gets close to the asymptotes on both sides. Then from pi to 2 pi, it's opening down and gets close to the asymptotes there. But again, doesn't cross them. Okay, so let's sketch this. Okay, so again, to graph cosecant, I'm going to start with my kind of original function, which is sine. That looks like this. Right, it starts at 0, goes up, and then back down. So my curve's kind of like this. Okay, now to make the graph of the reciprocal function, which is cosecant for sine, I'm going to start by making asymptotes anywhere that sine is 0, right? Because that's going to make the reciprocal undefined. So here are my asymptotes. Okay, and then I'm going to plot the points that cosecant has in common with sine, and then go in the opposite direction. So this curve opens up, and then the curve on this side will open down. Okay, and then they go on forever, right, as you get closer to pi. For example, sine is getting really, really small, so if I flip that fraction over, for example, if I'm like right here at like 1 over 50, if I look at the reciprocal of that, I'd be 50 over 1, so my secant graph is shooting way up, going bigger and bigger towards infinity. Okay, and then same thing down here, right? The sine values are getting really small but negative. So when I flip it, it's a really big negative number. So it goes up, down towards negative infinity. All right, now we're going to look at cotangent and tangent. So we'll look at them on Desmos first. All right, so here are my graphs for tangent and cotangent. These ones sort of overlap in more ways than the previous two. So this might be a little complicated to draw both at once, but let's just refresh our memory with what tangent looks like. So tangents here in purple, remember I have my asymptotes at pi halves and 3 pi halves, and it's going kind of uphill both times, right? It goes uphill, and then at 0, pi, and 2 pi, tangent is 0, and then kind of in between when we're at pi fourths, it's at -1, or I should, over here actually, at pi fourths we're at +1, at 3 pi fourths we're at -1, then 5 pi fourths it's at +1, right? So we plot those points and we get this sort of curving line, right, that's going, as I say, uphill, right? It's kind of increasing the whole time. So now let's look at cotangent. If I flip over to cotangent, you'll notice the red graph here is going downhill both times. So let's have tangent go away so it's a little less busy. Yeah, I'll hide the asymptotes. Let's look at these actually for a second. So these were the asymptotes for tangent that are here in blue. Okay, you'll notice they happen at pi halves and 3 pi halves. Now that we are taking the reciprocal for cotangent, the value is just 0 there. Okay, so where we had asymptotes before, now the graph is equal to 0. The function is equal to 0 there. Okay, so those are no longer asymptotes, but it looks like we do have an asymptote at pi, so let's highlight that, and at 2 pi as well. Okay, so to graph this, we're going to use these points that are our zeros. We'll use pi and 2 pi as our asymptotes, and then you'll notice now these are decreasing the whole time, right? It's going kind of downhill, then downhill, which is the opposite of how tangent was. So we'll remember that in our graph as well. Okay, so let's go ahead and sketch this. Okay, and for this graph, I'm not going to do the original tangent graph on the same set of axes just because it'll get a little too busy. But I am keeping tangent in mind as I make this graph. So I remember that tangent is 0 at 0, pi, and 2 pi, so that makes the reciprocal function have asymptotes there. Okay, and then tangent is undefined at pi halves and 3 pi halves, which makes cotangent equal to 0. Okay, so they kind of flip-flop where the zeros are and where the asymptotes are. Okay, and then cotangent, I remember, is going the opposite direction, so it's going downhill. That means right in between here at pi fourths, I'm at +1, and then at 3 pi fourths, I'm at -1. So I have kind of that downhill line, or the negative slope line. But remember, we can't just draw these in a line, right? We have a curve to it. The same pattern repeats over here, and our curves look something like this. Okay, they get close to the asymptote, but they don't cross. Alright, and once you have this written down, just think about some of these questions. This is what we discussed in class. We talked about what we learned today, which would be graphing reciprocal trig functions. How do we do that? So main thing to remember is that we base these off of the original 3 trig functions. Okay, and anywhere that the original is 0, we know that the reciprocal will be undefined. And it goes in the opposite direction. So we use the asymptotes and the direction to kind of allow us to sketch the graphs. How are they related to the other trig functions? Well, they're the reciprocal, so they have their shape kind of comes from it, right? They share some points, so like sine and cosine share the points where they're equal to +1 or -1. And tangent has a similar shape, right, but it's just facing a different direction. Then why do all of the reciprocal trig functions have asymptotes? You notice this, right, as we're graphing, cosecant, secant, and cotangent all have asymptotes. And that's really just because they're reciprocal trig functions, so they're always dividing by a trig function. So, for example, let's look at secant, which takes 1 divided by cosine theta, right, or cosine of x. So anytime that cosine is 0, this is going to be undefined. And for all of our original trig functions, there's always somewhere where it's equal to 0. So there's always going to be somewhere where this is undefined. Okay, if it's cosine, sine, or tangent, they all have somewhere where they're equal to 0. So that's why all of these reciprocal functions have asymptotes, or in other words, places where they are not defined. Alright, so that was it for today's lesson. Work on the homework for this, and I will see you tomorrow. Thanks.